Hello, friends. Today I'm going to discuss certain problems which was asked in JEST 2019, and these problems I'm discussing in particular those questions which were based on matrices. Okay, so let's start it. So consider this is the first question that was asked in JEST on matrices, this 2019. Consider the two n cross n matrices A and B such that A plus B is invertible. Define two the matrices C equal to A plus B inverse B and D equal to B A plus B inverse A. Which of the following relations always hold true? C equal to D, C inverse D, C inverse equals D, B C A equal to A D B, and D is of course C not equal to D. So let's try to solve this problem. So we have been given a C matrix like A e is equal to A into A plus B inverse B. Now you see we have A and B are two and cross and matrices, right? And it's such that the A plus B is invertible. That is, we can find the inverse of A plus B, which is A plus B inverse. So which is the following relations always hold true. Okay. So in the options, there is in C inverse equal to D and other options are there. So let me take the C inverse from here, which will give me B inverse A plus B A inverse. Okay, which I can open it up and make it like B inverse into identity plus uh, identity into A inverse. That is B inverse plus A inverse. Okay. And similarly, if I try to do it like D inverse, I try to find out D inverse. So D is given as B into A plus B inverse A, the inverse of this, which will give me A inverse A plus B, B inverse, which will be equal to uh, B inverse plus A inverse, okay, which is nothing but the C inverse. So in what we have found actually the D inverse is equal to the C inverse. Now if I operate C from the right, so I get D inverse C is equal to identity, and I operate now D from the left, so D inverse C is equal to D, and D inverse is identity, so C is equal to D. So which option is correct? A option is correct. So A option A is correct. Okay, so similarly, the second question, which was asked on the matrices itself in the JS 2019, that was let A be a Hermitian matrix and C and D be the unitary matrices. Okay, C and D are given as unitary matrix. Which one of the following matrices is unitary? So first of all, what is unitary matrix? So if we have a matrix U, square matrix U, such that U dagger is equal to identity matrix, then U is called the unitary matrix, where uh, U dagger means that the complex conjugate and then the transpose of the matrix. If you take taking transpose, means you convert the column into rows and rows into columns. And this is called the unitary matrix. So C and D are given to be unitary, and A is Hermitian. Hermitian is if you take the dagger, if it is equal to the A itself, then it is Hermitian, and C and D has are given to be unitary. That is, C dagger is equal to C inverse, and D dagger is equal to D inverse because of this property. All right, so now we have to show that which one of the following matrices is unitary. So let me choose the option A first. So if I take the option A first, so C inverse AC. So if it is unitary, then uh, its dagger will be C inverse, right? If I like C inverse AC and write down C inverse AC dagger, so this should give me identity. So let me check what does it give me. So we have just seen that the C inverse is actually C dagger because C is unitary. C is given to be unitary. So I write down in place of C inverse as C dagger A C dagger, and this gives me C dagger A C and C dagger A dagger C. So this gives me now C dagger A C C dagger A dagger C. This is identity. C dagger A dagger C. Now A dagger and A are same, so C dagger A square C, which is not giving me identity. So option A is not correct. So let me check option B. Option B, C inverse D C multiplied by C inverse D C dagger. So this gives me C inverse is nothing but C dagger. We have just seen C dagger C DC, C dagger DC dagger, and this gives me C dagger DC. And I take the dagger, it gives me C D dagger, C dagger C C dagger is identity, and then D dagger C. So in other words, what we are going to get is the following. So this is identity here. So I'm going to get C dagger, D dagger, D dagger C. D dagger C is again identity. D dagger is again identity. So C dagger C, which is again identity. So because C and D both are unitary. So in other words, option B satisfy the condition of a unitary matrix. So option B is the right answer. If we check for C and D, we will not get that. If we multiply this matrix with its own dagger, you will not get identity. Similarly, the same is true for this. So option B is correct. B is correct. Okay, in the so this is the third question, which was asked in JS 2019 on matrices, and this was the last question. I mean, only these three questions were asked in JS 2019 on matrices. So what this is a simple, rather simpler one because we have been given a matrix A, consider 2 cross 2 matrix A, which is 11301. What is the A to the power 27 that we have been asked to find out? So for example, if I write A square, so what will that be? That will be 1 here and 26 here and 1 here. If I calculate as a cube, this is going to give me, okay, so what will be a to the power 27? 8 to the power 27 would be 1 into 27 into 1301, which will be 1 is 27 into 13 is 351. Okay, and this is 01. So which option is matching? Option D is matching. So we have the answer as option D. So that's it for today, friends. And in the next videos, I will try to discuss more questions on asked on matrices in different years of JST, FR, and other exams. Thank you so much.